Due to internet connection, it was disconnected again. So I was drawn the diagram, that is, if the primary winding, I will draw first. The primary winding, this one. So the secondary winding is, this is the secondary winding, that is called S1, and this one I will consider as S2 here now. This is S2. So middle, the core we are going to consider, I am going to consider the core as this one and this one here. So this is the core we are going to consider. At middle, the shaft we have connected here. We have connected the shaft here. So it is equally connecting to the S1 and S2. That is called the EMF induced in the S1 and S2 will be same. On that condition, we will consider as null position. And I told if it is clockwise direction, on that condition, this shaft is there, this moving iron, what it will do, it will move like this here now. So it will, the end, one end of that iron piece come nearer to the S1 and other end will go to the primary side here now, which will give the more flux linkage to the S1 only. So the EMF induced in the ES1 is greater than ES2. On that condition, the net output will be positive here. The net output of the differential transformer is positive. Differential output will be positive. Suppose, I'll keep here only this one. Okay. Next one. So the third condition is that when the core rotates in anti-clockwise direction. This one I have not read in this one. Yes, okay. When the core RVDT rotates in the clockwise direction, then in this case, the flux linkage with S1 will be more as compared to the S2 here now. Just now, whatever I have explained, same thing they are telling here now. If it is rotated in the clockwise direction, if it is rotated in the clockwise direction, and then in this case, the flux linkage with S1 will be more as compared to the S2 here now. See here, the space between core and S1 is this much only. But here, this much displacement or difference is there for S2 and the core here now. Middle, it is completely away from the S1 only here now. So the flux linkage with S1 will be more as compared to S2. So this means that EMF induced in S1 will be more than in EMF induced in the S2 here. So S1 has more flux linkage. It has more flux linkage. It has less flux linkage here now. So then if the flux linkage is more, then the EMF induced will be more or less. If the flux linkage is more, then EMF induced will be more or less.
More.
More, obviously here. Which winding it has more flux linkage?
S1.
S1 is having more flux linkage. S2 is having? As compared to S1, S2 is having less flux linkage. So the EMF induced in this one is less here, no? So ES1 is greater than ES2. Hence, ES1 is greater than ES2. And the net differential output voltage, we know the formula, that is E0 equal to ES1 minus ES2. So ES1 is greater than ES2. So that is called positive. We are going to get here now. The output will be positive. This means that the output voltage E0 will be in phase with the primary winding here. It is in positive means it is in phase only here now. It is in phase with the primary winding. We are going to call that one. This is the second condition. Next, we'll go for the third condition. Suppose when the core rotates in the anti-clockwise direction. See here, I will use another. Remove this one. ये remove नहीं हो रहा है ना? ठीक है. We'll check. So this one I will remove. This one I will remove. Now is it visible? So in the anti-clockwise means left to right or right to left? Which one? This one? Clock will rotate in this direction. So anti-clockwise means opposite to that one here. So secondary to the primary side, it is nothing but. So in this condition, you only okay. In this condition, you people only tell. I will just draw the diagram according to this one. So anti-clockwise direction means it should have to rotate in this part here. Now this core is there, it is going to rotate in this part here. It will be like this. It will be like this. The core will be like this here. You can tell that one which coil is connecting more and which more flux linkages and which coil is having producing more voltage here, now inducing the more EMF. You people only tell me. Yes. I'm asking to you people only. It's audible?
Yes, sir.
Okay. वो तो बहुत परफेक्टली बोल देते हैं यस सर बोल के, बट आंसर आई एम आस्किंग हियर नाउ.
सर परत सांगा. Repeat, sir.
Listen carefully. This is, I will remove the core. Inside the core है ना, वो white color I will remove completely. This white color is core is not there here now. Okay, you can check that. So this is the yellow color is your core now. So it is connected with which S1 is connecting. It is nearer to the S1 or nearer to the S2 here.
S2.
So it has suppose here one person is there, you are there here now, person primary, here secondary. Just a minute, I will draw here एक person है, that is P. I will write here now. Either two persons are there here, two persons are there, A and B here, A and B. हमको A and B should have to connect to the P. ये P को connection करना है, ये है ना, दोनों को एक एक हाथ देगा ये. This is called null position. दोनों को एक एक हाथ दिया ना, equally he is supporting to them to stand over there. Yes or no? So that is called null position we are going to call. Instead of providing both the hands, what he will do, he will provide only one hand to A here now. There is no flux linkage, or flux linkage only इधर तक की hand A ऐसा put करते. So more flux linkage is there for the A1. So in the second case, what it will do, he will give left hand, right hand to this person here now. He will not give to this one here now. The subflux linkage will be more. And that condition, what I am telling here now, in this condition, from the clockwise direction, it was rotating like this. The S1 was connecting to the core here more. And that condition, flux linkage in the S1 will be more. But now, what I am asking here, see here, by seeing the diagram of this one, this is the diagram. Here the primary winding is there. Here secondary windings are there. S1 and S2. So if it is from the initial position to anti-clockwise, it is rotating here. No. So from primary to secondary windings are two windings are there. Which one is nearer and which winding is connecting more flux linkage here? No.
S2 winding.
S2 winding is nearer to this core here. No. So primary here, the magnetic flux is there. It is directly connecting to the S2 here, no? So for the primary S2, S1 winding, it has some differences here, no? It is connecting less flux linkages will be there for the S1 winding here, no? For that reason, so S2 is having the more flux linkage. So the EMF induced in the S2, EMF induced in the S2 winding is greater than EMF induced in the S1 winding here. So on that condition, so ES1, we know the formula, the net output formula is ES1 minus ES2. So ES2 is greater than ES1 here, no? हमने secondary winding ES2 is greater than ES1. So E naught equal to ES1 minus ES2 is there. So output will be in positive or negative?
Negative.
Negative here now. So because ES2 is bigger one here now, so that is called the output will be negative here. So that condition we are going to get the answer in negative, we are going to get here. So that is called, so whatever the input is positive is there, output is negative, we are going to get here now. So that is out of phase we are going to call, RF, which is opposition to the in phase, we can call that one. Opposition to the in phase, we can call that one here. That one only we have written here now. When the core of RVDT, when the core of RVDT rotates in anti-clockwise direction, then in this case, the flux linkage with S2 will be more as compared to the S1 here. The flux linkage of the S2 will be more as compared to the S1. This means that EMF induced in the S2 will be more than EMF induced in the S1. So S1's EMF induced in the S1 is less than EMF induced in the S2, or EMF induced in the S2 is greater than EMF induced in the S1. So we know the formula, that is E naught equal to ES1 minus ES2. So by doing this one, ES2 is greater than ES1. So the output will be negative here. Output will be negative. This means that output voltage E naught will be in phase opposition. That is called 180-degree out of phase here. No, it is out of phase with the primary voltage, we are going to call that. So these are the three conditions are there, that is at null position. First one is when the core is at null position, there is no movement at all here. No, at equally part it is connected to that. Equally it has connected here now, like this. This is S1 को उतना ही connect हो गए, S2 को भी उतना ही connect हो गए. On that condition, null position we are going to call. If it is in the clockwise direction, then S1 को is connected to more and S2 is connected less here now. So on that condition, S1 is greater than S2. So ES1 is greater than S2. So the output will be positive. We are going to get positive. For the anti-clockwise direction, ES1 is less than ES2. So on that condition, the answer will be negative here. Three conditions are there. So all the three conditions we have discussed here now. When the core is at null position, output is 0. When the core is rotates in the clockwise direction, output is positive. When the core rotates in the anti-clockwise direction, the output will be negative here now. So the RVDT has some advantages because it is angular displacement it is going to give. So it is going to give high accuracy. Size is very less. Small rotating part we are using here now. So compact and strong construction is there. The consistency of RVDT is very high. It has a long lifespan is there and very high resolutions are there. Cost is less because only small instrument we are going to consider. So durability is high. Linearity is excellent here now. Whatever the displacement is there, same output it is going to give over there. So that is linearly it is going to give the output in the angular displacement. As per the angular displacement, the performance is repeatable. So एक बार एक rotation हो गए तो इधर it will not stop over there. It is repeatably we are going to call and it is easy to handle also here. So we are going to use this RVDTs in some different applications, that is machine tools we are going to use, brake with cable systems we are going to use, and weapons we are going to use, engine fuel controls we are going to use, aircraft, engine bleed, air system, robotics may use karte. So different applications are there. We are going to use this RVDTs. So it completes the transducer part completely. Transducer part is completed, and tomorrow class we'll discuss about the instrument transformer. If you have any doubts, what are the concepts we have discussed? That is, first one is RTC, RTD, LVDT, and RVDT. These four concepts we have discussed in the transducer. So you prepare well for these all the four topics. If you have any doubts, you can contact me. Okay. So any doubts we have? The transducers? Anyone want to ask anything? Yes. Yes or no? If you have any doubts?
No, sir.
Okay. So we'll stop here only. And in the next class, what we'll start the instrument transformer part will start, and we'll continue in the next class.